Thanks, Kathy, and welcome everybody. My name's Ken Beer. I think I have met some of you in various road safety ventures in New South Wales, but I'll introduce myself a little bit more shortly. And with me, I've got Kathy Decoris here, and Kathy is the training manager at Safe System Solutions. So I'm going to start off with a few of the logistics and admin side of things, and I'm going to share a few slides to get going, and we'll tell you about how the Zoom webinar works and how you can interact with us and all that shortly. I might start by acknowledging the traditional owners of the many lands on which we are running this training, and we do have many lands. We've got people from a variety of areas of New South Wales. And Kathy and I are based in Melbourne. So I pay my respects to the elders past, present and emerging from all the lands on which the training is being run. Now, Kathy, you seeing my slides?
All good.
All right, well, I'll let you talk to this one then.
Terrific, thank you, Ken. So if you're having any difficulties at all with accessing Zoom or Schoology, please get in touch with me. You can text me, you can email me, you can call me, any admin questions at all. Throughout the session, as Ken mentioned, we don't have your audio or video on, but if we can activate your audio, and basically the best ways to chat with us is using the chat function, if that one's available to you. I know some people in Transport for New South Wales don't have chat. So you can use the Q&A functionality basically to ask questions or make comments throughout. And do make comments throughout the session. Don't wait until we pause for questions, ask away, and then we will pause at various times throughout the session. If you would like to speak to us verbally, you can raise your hand and lower your hand. You can practice that now if you like. And basically we can unmute you. Terrific, thank you. And you can ask your question or make a comment that way. If for any reason Zoom is failing you, probably the best thing to do is to shut down and restart. And if that doesn't help, then you can dial into the session. Your slides are in Schoology and on the USB if you've received your pack, so you can access it that way. Get in touch with me, as mentioned, at any stage.
Thanks, Kathy.
Yeah.
This is me, Ken Beer, Principal Engineer at Safe System Solutions. That's me without my lovely moustache. And I've chucked in there a QR code to my LinkedIn. So I'm pretty sure you all know how to use a QR code, but you just use your phone and hover the camera, turn the camera on, hover it over that, and it'll direct you to my LinkedIn page. And the reason I want to do that is that we're going to go through these modules and you're going to have lots of learnings and discussions around safe system and safe system assessments, but we really do want to continue that conversation and share updated information and learnings, and that's a good way to do it. So I'll have that QR code down the bottom throughout the slides as well if you want to use that at any point. But throughout this training course, any technical questions, get in contact with me. My contact details are there. So if you're struggling with any of the assignments or you want clarity on a different point that was made, or you want to question something, please get in contact with me, phone, email, happy to chat, happy to organise a one-on-one Zoom or something if we need to delve into an issue in detail. Kathy, explain this Schoology thing.
Schoology, thank you, Ken. It's basically a learning management system which houses everything that we need for this program. A lot of you have jumped on and joined the course already, which is great, and introduced yourselves, so thank you for that. At the end of each module, this is where the recording will be saved. So in each module folder is where I'll save the recording. There is a short multiple choice quiz questionnaire for you to do at the end of each module, and again, that is in Schoology. There'll be a couple of assignments for you to do, one being your safe system assessment if you're in that part of the program. And again, you'll access that and submit it through Schoology. Schoology tends to work at its best when you're using Google Chrome, we found. So if you're having any trouble, flick over to Chrome and see if that helps. Otherwise, again, please get in touch with me.
Thanks, Kathy. And Schoology is the go-to place for everything. And hopefully some of you received a pack with a memory stick, and that memory stick contains all the information that is also on Schoology. So if you haven't got a pack, don't worry. It's just you're able to access Schoology and get all of that information and download it through that platform anyway. So there's a little creature here, Wally the Wombat. Wally the Wombat warning sign. And Wally appears a number of times through each module. And this is a little way that we like to ensure that you're concentrating on the content we're providing, and you're watching the slides and listening and interacting. I know it's tempting to do emails and to continue doing your roundabout design or whatever you're up to, but we do want you to try to interact with us in this electronic environment. So Wally's going to appear a number of times, and you have to count how many times Wally appears throughout the module. And when you get to that multiple choice quiz that Kathy mentioned in Schoology, one of the questions will be, how many times did Wally appear in this module? And you have to pop in that number. And we give you a little bit of tolerance either side in case you were out getting a coffee or something, but we do want you to try to be pretty accurate. So this, I should say, this is not one of the Wallies. So your count is 0 at the moment. You have 0 Wallies, but keep an eye out for them. And the requirements of this course for successful completion for the Safe System Assessment course to get the certificate is to attend 4 out of the 5 live webinars. All the webinars are recorded, so if we know you're busy and you've got a lot on, and there's some things that can't be moved, so you can watch the recording of one of them, but you still have to do the quizzes and assignments. We need you to satisfactorily complete all the set tasks, the quizzes, the assignments, and the actual assessment itself. And we need you to achieve an 80% pass mark for all the quizzes and assignments. Now, don't get too concerned by that. It's a high benchmark to set, but we really do want to ensure that the competency is up there. But we are here to ensure that you do get above that 80%. So if you have a go at a quiz and you don't do very well, you might want to consider getting in contact with us at that point, and we can organise a chat or help you with some information about the specific areas that you might be struggling on. So our aim is to make sure you get that 80% plus for the assignments. You've got 3 attempts at everything. So as I say, have a first go at it, but then if you're struggling in the results of that, get in contact. And if you submit your assignment and we think it would be valuable for you to do a resubmit on it, we'll let you know that. Anything to add there, Kathy?
I think you've covered it all, Ken. Get into it.
Well, if anybody has any questions about the running of the course, pop them into the Q&A or the chat as we go, and Kathy will deal with those. So the way this works is that I sort of cover off some of the content and ask you a few different questions and run a few different polls and the like. And Kathy works behind the scenes and collates the different questions, feeds those to me, pops the polls up and the like. And Kathy also gives away prizes. And you'll see she's in the prize pit. And so many prizes there. So if you are the first to answer things correctly in the Q&A or the chat, you may win one of those prizes. Oh, What do we got? What's first on offer? Oh, it's a pair of socks. First on offer prize. So there you go. And it could be anything. Could be socks, could be chocolates, could be a Superman doll, who knows? But all of these things are available if you're interacting. So when we get to different points, be ready with your fingers to type as quickly as you can, because that's the first correct answer wins the prize. And the way we get those prizes to you is at the end, once you successfully get past that 80% mark and have finished everything off, we email you a certificate, but we also mail you a hard copy of the certificate. And in the pack with your certificate, we also pack any prizes that you've won along the journey with us. We really encourage people to get into the sessions a little bit early to, in case the technology is not working too well for people. So we also incentivize you in that front. And 3 minutes or so before the start of every module, we run a little bit of trivia. It could be general knowledge trivia, it could be road safety trivia, but there's a chance to win prizes before the modules even begin. So log in a little bit early and there'll be a chance to win a prize. All right, get those questions or comments in as we go. Kathy will monitor that. I'll just run through a bit of content. So you're here for the Safe System Assessment training course. Some of you are doing sort of Safe System Principles, which is the first 3 modules, and some of you are doing the full modules. The principles of the Safe System, which we start with, are really to ensure we're all on the same page, but also prime us and start us thinking in some specific ways, which is what a safe system assessment is all about. And I'm going to run through some of that at a very high level to start with. And as we go through the modules, we hone it down to some very specific techniques for safe system assessments, for investigating infrastructure or other elements of the safe system, for their alignment with safe system principles. And hopefully this will all make a lot more sense as we run through it. So by the end of this module, so this session we're running now, we want you to be able to list the principles and elements of the safe system. We're going to talk about kinetic energy thresholds in different crash types, so the forces in different crash types. We're going to have a talk about the difference in the traditional approach to road safety that we've been doing for a long time and the safe system approaches, which is what we're moving to. We're going to have a chat about best practice in behavioural change and vehicle safety interventions. And we're going to talk about speed. I'm going to talk about the importance of speed within the safe system approach. Now there's your first Wally. I'm being nice to you on this one. Your Wally count is 1 at this stage, but no more me being nice with Wallies. You're going to have to keep your eyes peeled and see if you can count all the Wallies as we go. So the safe system, the safe system as a philosophy and a concept and a way to operate a road network has been committed to in strategy. So here we've got the New South Wales Road Safety Plan 2021, and this one and the ones that are coming after it are all committed to the implementation of the safe system. And so we're in. We've got to do this. It says it in that. It says it in all the different jurisdictions, strategies. It says it in the national strategy. Even actually at a UN level, we've got a commitment to the safe system. So we're in. We're absolutely in. And interestingly, we've been in for quite a while on this idea of the safe system and the way of operating. And I'm going to give a prize out. The person who can tell me what year the federal government in Australia signed up to the implementation of the safe system as a way we're going to take this safe system philosophy and we're going to implement it. So just pop that into the Q&A or the chat. Have a guess at the year, and the person who gets that year, you can have multiple guesses if you want, will win the prize. And you can have multiple guesses. We're seeing a few coming in at the moment. Kathy, I assume you're monitoring. Oh, good. Look, they're all coming in nicely. Nobody's quite got it yet. Maybe we'll keep guessing. Okay, lots of good guesses. I think we're going to go with closest there, Kathy.
We are going to go with closest. And it's Baker. Are you Baker? I can't quite grab the first name.
It's Jay Baker, is it? Is that Joe? It might be Joe.
Jason. There we go. Jason from Byron. He had 2003, but the actual answer is
2004. So pretty good guess on that. So 2004 is where we signed up to the implementation of this in the safe system. So that's what, 16 years ago, and so you'd think it is something that we're very well progressed in, but it's taken a long time for, I suppose, people to get to know it, to get some traction, to get some commitment, and it's really now starting to make its way out there as a philosophy. A lot of local governments are committed, have strategies around the implementation of the safe system. A lot of people know a little bit of the terminology around the safe system, but maybe not the intricacies of implementation of it. And this course really delves us into some of those on-ground decisions in projects or education initiatives or anything that we're doing, as to determining how well it aligns with this philosophy of the safe system, which I haven't even got to explaining yet. But I do think that that's interesting to know that this is not a new thing. It's something that's been around for quite a while. Do keep those questions coming in. So you've proven now you have the ability to type in. Let's utilise that. Now, this diagram is one of the very early diagrams of the safe system. Lots of diagrams have come after it, but this is one of the very early diagrams of the safe system. And I put this up for a couple of reasons. First reason is that, I'll run through it. We've got these elements of the safe system, and we've got the speed here, and we've got the roads and roadsides, and we've got the vehicles. And we are trying to get these elements safer. In the middle of this old diagram of the safe system was this human tolerance to physical force. So acknowledging that humans can't handle unlimited force before we break, or we're killed, or we're seriously injured. Then there's this circle out here, and that's actually where the first sort of diagrams of the safe system stopped. That was it. It said, that's our system. And then at a very sort of last minute before it was introduced into policy and the like, there was this little bit added as this sort of overarching entity. Alert and compliant road users. There was a lot of us in the game at that stage who thought that this was a step backwards. It's a bit of a failure. And the reason we thought that was that this sort of goes somewhat against the philosophy of the safe system to a degree. The reason is that we know that we have humans operating within this system, and humans are not alert all the time, and they are not compliant all the time. We can look to make them more alert and more compliant, but getting absolute alertness and absolute compliance is an impossibility if humans are operating the system. And so it was kind of seen that this is a bit of a get out clause for those of us that manage and operate the system to say, well, they weren't alert, or they fell asleep, or they ran the red light. That it's not. We can't do anything about this. They've got to learn to drive better. The pedestrian was walked straight out in front of traffic. We're actually there voiding ourselves of looking at any part of the system we could alter to either minimize the harm that would happen in any crash, or look for ways that we could, using these other elements of the system, minimize the chance that happens. So that one, probably not a great thing for us to have had in for quite a while within the SAFE system in those words. The evolutions of the SAFE system then sort of came about where there were different diagrams popped up, and you've probably recognized many of them. This one in particular you've probably seen, and there's this one, and I'm probably going to talk to this one because it's the pretty close to the current one that New South Wales tends to use. Work to prevent crashes that result in death or serious injury. So we're really targeting that high-end severity crash. And there's a little sort of hidden bit of information in that, in what's not said. We're not targeting the minor crashes. And in fact, we're accepting the fact that minor crashes, minor injuries, bumps, scrapes, fender benders will all continue to happen, because mistakes are going to continue to happen. But what we need to be looking at doing is managing the energy within those and working to reduce the deaths and serious injuries. And this is all based on how much force we can handle as humans, which we're going to talk a lot about over this course. And we've got the elements of the roads, the vehicles, the speeds, and the people that we can use as levers to get us to these positions. So the people are still in there. And so when I crossed out that last one, it was not to say that we are going to ignore trying to get better improvement out of people. It's to say that we can get some improvement, but the idea of having these humans that never make any mistakes out there on the road network is completely ridiculous. That will never happen. You would have to, well, we have to remove humans out of the system completely in order for that to happen. And you'll see around the outside here, we've got some wonderful sort of underpinning or overarching elements and things that we can do. And we'll go through those in a bit of detail. The other important thing to understand is that this is a system, and it's a system that interacts with each other. These are not standalone pillars. They're elements that all interact in quite a complex way. And that's an important thing to be thinking about, the interaction between these, all of these elements. Some key principles in the SAFE system. We have this aspiration of zero death and serious injuries. We know it's a long way away, but we need to be working towards that and getting our mind, our head in the space that no death or serious injury is acceptable, or something that we just say, well, you know, that's part of managing and running and operating a road network. We need to remove that sort of thinking. We've talked about the vulnerability of people. We're going to come back to that in a lot more detail. We've acknowledged that people make mistakes and they will continue to make mistakes. That is part of being human, and we need to start designing for that. And we have a shared responsibility. There is no more sort of blame. It's looking at a system failure, looking objectively at that system failure and trying to understand what can be done with all elements of the system to mean that either that doesn't happen again, or the harm is minimized significantly in terms of the severity of the crash. So get your questions or comments coming in, but I'm going to take you through a little analogy, which I like to do, because I've made some pretty sort of big statements already. I've talked about zero death and serious injury as an aspiration. A lot of people just, completely switch off. They go, that is absolutely ridiculous. You got your head in the clouds. This is a massive road network. It's got so many people using it, and there's all sorts of ridiculous things that happen out there. There's no way we could possibly ever get to zero death and serious injury. And I think that we need to start looking at other industries to try and understand how they've made significant gains in safety. The first thing I'd say is that we want to get to virtually zero. So potentially we could even just say we want to bring ourselves in par with virtually every other industry out there. I mean, road trauma is so out of proportion in terms of the death and serious injury acceptance that it's just astronomically out of proportion. And so I'm going to use the industry of manufacturing as a little analogy, and very different industry, but a lot of parallels in terms of the safety culture thinking. So if we go back in the day, and there were factories making widgets, and they were churning out their widgets using these machines, and their system was fairly open in terms of people. They had some employees, people that they paid to do stuff, and were admitted in there. But they also used to get others sort of coming in and selling stuff and trading and wandering around, and then people cleaning who were just sort of paid a little bit of money here and there or whatever it was. So it was a fairly open system to a degree, and it was quite a dangerous environment. I mean, we had these machines, and we saw quite a bit of death and serious injury in these manufacturing plants and the factories and the like. And what we would sort of term that sort of safety culture, where they tell the workers, hey, this is dangerous machinery, use it this way, and don't go over near that machine and the like. This is kind of what we call the pathological safety culture, where it's up to everybody to protect themselves the best they can. They're told it's dangerous, and they're asked. They say it's up to you. Protect yourself. We sort of elevate up in these to the next sort of safety culture, which is the reactive safety culture, which is to start to address and solve these problems of machines killing people, ripping kids' arms off and legs off, and start to address those as they pop up. So, okay, that machine's killed somebody in this way. Maybe we put a little bit of a guard on it here. Okay, that machine's ripping arms off quite a bit. Maybe we need to change the way we configure that. So this is sort of the reactive safety culture. Then the economists start getting involved. And this is what we call then the calculating safety culture. And this is where an economist comes in and looks at the factory and maybe the other factories that the owner is operating and says, you've got a fair bit of lost time here in the machines being down, and you're paying out a fair bit of money to the family of the people who have been killed and people who are losing their limbs and the like. I've done a bit of a calculation, and if you actually spend £20,000, it's pounds back in these days, you will actually see a return of £60,000 through increased widget production and less money paid out to injured and killed workers and their families. So I've come up with this new concept called a benefit cost ratio, and it's a benefit cost ratio of 3. So you get £3 return on every pound invested in these safety improvements. And so this is about finding that balance between safety in widget production, or safety and mobility, as I think you're starting to see in the analogy that I'm putting forward. But then where we elevate to next is to say, this is the acceptable safety level, and it is very high. We have an extremely high level of safety required, and we will raise the widget production up with as long as we sit within that level of safety. So safety sets the precondition for widget production or mobility. And that is this proactive safety culture, which the SAFE system is all about, that proactive safety culture. Once you've got to those proactive safety cultures, you need to invest in maintaining that high level of safety. And it is a continual investment in maintenance of the culture and maintenance of any systems that you have in place. So where do we sit within a transport system, I suppose, is the question, our road network? Well, I would say that we have elements in most of these categories in terms of our culture. But there is a huge amount of pathological safety culture in our road transport network at the moment. We are licensing and sending people out into a very dangerous scenario, but telling them it is their responsibility to protect themselves the best they can. Certainly, we're not voiding responsibility under these proactive safety cultures, but we're recognizing that is not a high-level safety culture to be doing that. We've got elements of reactive, so certainly black spot programs or just individual spot treatments as crashes happen. We have the calculating element with different. Well, there's a huge amount of economics around investment, around benefit cost ratios, black spot programs, and the like. And there's bits of proactive coming into play within the transport road network. These are often things that we accept and take for granted. I dare say things like school speed zones are a proactive safety culture mechanism where we've determined that we don't need to wait for enough kids to be struck or killed or seriously injured in these areas before we're going to start to address the risk that we know is there. Likewise, we're not doing a benefit cost ratio on the implementation of school speed zones. Interestingly, I did that once, and it is a horrible, horrible investment from an economist's calculation point of view. There is simply not enough kids killed or seriously injured if you're going to take that attitude. And yet the community is aware enough to say that this is unacceptable in our community, that we need to be setting a higher bar on safety around these schools. And we don't care what your benefit cost ratio spits out. It's the right thing to do. It's the ethically correct thing to do. So there is hope, and there are those sorts of examples and the like that we have available to us. And I'm happy to talk a little bit about the how you would calculate that benefit cost ratio and the sort of morbid nature of BCRs that we have in terms of being slightly against the ethical imperative of the SAFE system. Now, Kathy, any questions or comments coming at this stage?
Yes, we do. Thank you, Ken. So some comments here about manufacturing is a controlled environment and not open to the weather, unlike roads.
Yep. So that's right. The weather is one of the elements that we certainly have to deal with, which is slightly different. There's a number of others, but at a sort of safety culture sense, in the way that safety is viewed, these are, I suppose, a very relevant comparison. But I dare say that we could do exactly the same with rail transport. We could do it with shipping. We could do it with aviation, all of which are exposed to the weather and the elements, yet their safety culture is just poles apart from what ours on the road transport system are. Now, you might say, well, they're closed systems and have professional drivers and pilots and the like. But, you know, they're coming still from an origin of the same sort of transport, transport of people and goods.
There's a question here about, are we missing the element of road user responsibilities? Road users choose to use our roads. It's not a right, it's a privilege that is secured through a driver's license. Are we missing a major element by excluding the primary stakeholder? And could a safety culture be improved by including a safety module when getting L's or P's or renewing your license, a bit like a toolbox?
I'll talk a little bit more about some of those sort of things shortly, but I slightly question the premise of that question, in the sense that we have a choice in a huge number of things in society, yet we don't accept a level of potential death and serious injury in a lot of them. In some of them we do. But stepping onto a train, for example, you have a choice as to whether you get on a train or not, and choose that form of transport. You bought a ticket, you get in there, and you rightly expect to every time turn up to your destination without the train, taking your life or seriously injuring you. And that is sort of where we're just culturally different in terms of the road system, because of the way we've all grown up with it. It's how we've grown up. So I would say that we can sort of change these things. And the biggest temptation is just to try to push this back to the individual road user. That's the easy way out. And unfortunately, over many, many years, we've seen that we're limited in the success we can get out of that. We certainly can get success, and we do get success, and I'll show you some of the ways we can do it, and I think some of you are thinking along those lines anyway. But we need a fundamental transformation of the whole system in order to get us to comparative sort of death and serious injury rates or safety culture levels of almost all other industries, especially in transport. So I'll talk a little bit more about that. I will talk about more about these challenging individual road user decisions and the like shortly. But you have to slightly alter your thinking when you're managing a whole system to be understanding that that is part of our society, and it will be until we start genetically engineering humans, basically. Any other questions there, Kathy?
We've got lots of questions and comments coming through, Ken. Very active group, which is great. So how are we creating pathological or self-responsibility by licensing from authorities?
Yeah, so it's not the licensing as such that creates the pathological safety culture. It's it's part of our legislation and the culture that says the road user has ultimate responsibility for their own safety, and you need to start altering your perception on that to say that the system managers have ultimate responsibility for everybody's safety. The individual has a responsibility to do a decent task within the system, understanding that they're a human, that they are a human, a fallible human who makes mistakes all the time. And I'm not going to get you to write in all the mistakes that you've made in your life or in the last 5 minutes or 10 minutes, but gee, we'd all write a lot of stuff in. That's part of being human. We make mistakes, we learn from mistakes, we alter things. It's just who we are. So the idea to try to eliminate mistakes from the transport system is ridiculous. Minimize and manage is what we need to do. Minimize and manage. And the pathological part of it is just to push somebody into a inherently unsafe system and tell them that it's their responsibility to be safe in there.
Can I go off script here and jump in with a story, if that's all right?
Is it going to be a story of your mistakes?
No, that'll go on for too long. But just what you've been talking about with the safety culture in manufacturing, I spent some time a long time ago working in a print shop, and there was this incredible guillotine type machine that sliced through big wads, like stacks of paper. And obviously people had lost hands and fingers and all sorts of things in this machine. So it had 2 buttons either side to activate it. So you needed both hands to be out of the way of the machine, press the buttons at the same time to activate the guillotine. Now, obviously that wasn't enough. And so it was also fitted with like a laser. So if anything broke that laser whilst it was in action, it would shut it down. So it's really interesting to see that that's the sort of system that's in place there, knowing that people are going to put their hands in to try and fix it. And then you get out on the road, and the only thing that stops your highly powered machine from hitting another highly powered machine is a bit of white line painted on the road. So, and an understanding that everyone should stick to their side, but it doesn't always happen. So it's just interesting, the differences in the different spaces as you've been talking about.
I'd like to extend on that, Kathy. There's this sort of systemic element to it as well, that it won't only be that guillotine machine, but every guillotine machine in every print factory will be required to be fitted with the equivalent safety mechanisms, because you don't have to wait for somebody to have their arm chopped off or their fingers chopped off in that particular machine. The machines are dangerous. We know high-speed intersections are dangerous, and we know that a white line or high-speed roads. So I absolutely agree, and it's another great analogy. And I'm sure people out there now are thinking of different analogies and things that are. We accept a level of death and serious injury and the like on the road network, and we just do not accept that in other industries and other environments.
We've got more questions. Within the model of safety culture, it is accepted that various work groups will be at different levels of cultural maturity concurrently. Do you consider that different subcategories of drivers, all from different regions, etc., will be at different levels of cultural maturity? And how do you propose to control for that variance?
Yeah. So the first thing is that I'd say this safety culture simplicity of this diagram is, it's been made very simple for an online module and the like, and it's very complex. The part of that question, though, that I think we should alter in terms of our thinking is that we're targeting the individual road users. Where I would say this safety culture is much more applicable is the way we manage the road network. So the road managers, the road designers, the system creators, the licensors, the people who register vehicle, all of that side of things before you're at that end road user and their sort of safety culture. So we really need to focus on that system designer, I call it, and that's everybody involved in the creation of the system.
Another question, doesn't it come down to funding?
Yeah, so it comes down to a lot of things, funding being a big one. Funding, political acceptance, community community acceptance in terms of what people are used to and people's willingness to change. Cultural norms, and a huge raft of other things. I would dare say that knowledge and technology is part of the challenge. We just don't have ways to treat some things that are within the bounds of acceptance that we have. So a huge number of things factor into this. Cost is an easy one to use to say, well, we can't do that because we don't have enough funds. There's a lot of examples out there of things that are very low cost that have significant improvements. There's also, at an individual council level or an individual regional level, there's quite a huge amount of funding available. And I'll often, talk with councils or regional officers from RMS or the like, and actually the amount of money available is not the issue. It's their capacity to deliver it, or the community's acceptance. They believe the community won't accept that, or the local members adamantly against, I don't know, central barrier systems or something like that. And so I think to say funding is holding everything back is part of the issue, but there's a lot of other things for us to work through. This is good, Kathy. Lots of good conversation and interaction. In fact, every time I run their session in New South Wales in person, we always get great discussion, and it's good. And we want people to challenge this and try and see if they believe in some of these things being presented, or if they have slightly different views on it that end us in the same spot. So we're not obsessed with this particular way of thinking. What we're obsessed with is that end outcome of as close as possible to zero death and serious injury on our road network. Okay. Well, let's get them doing something. Now, you only have two questions that are going to pop up on your on your screen. One of them you should have the answer to. The second one you did not have the answer to, so you're going to have a guess at it. You're not marked on these. It's not part of the actual marking. These are just for interaction. And for those who can't see it come up, if you can't see anything pop up on your screen now, the two questions are: which one of the following is not a key principle of the SAFE system? Aim for no death or serious injury, aim for no mistakes on the road. People are vulnerable, people make mistakes, and we have a shared responsibility. And the second one is asking what speed Usain Bolt crossed the finish line in his world record 100-meter sprint back in Germany when he did that. And the options are 24 kilometres an hour, 34 kilometres an hour, 44 kilometres an hour, 54 kilometres an hour, 64 kilometres an hour. And we're getting lots of guesses come in. But if you can't see that, you could write it into the chat if you want, or you can just sit back and wait until we discuss the answers.
We might take one more question whilst people are doing that, Ken.
Yeah.
Or maybe it's more of a comment. When it comes to safer vehicles, we still struggle with the manufacture of vehicles capable of speeds that are multiple times our highest speed limits.
Yeah. So a challenge that has been in the road safety game for a very, very long time, and we really struggle to compete against these multinational trillion-dollar companies who have the objective to sell their vehicles in whichever way they believe they can sell it. We have a culture, community culture now, which speed is still almost put on a pedestal. In fact, it is literally put on a pedestal in car racing. And it precipitates a very challenging culture for addressing that sort of thing. So what we're seeing though is a little bit of forward movement in Europe in some maximum speeds for registered vehicles. Admittedly, they're pretty high. They're 180 kilometers per hour is maximum speed that they are now going to be accepting for any car on the public road network. It's a start, but I will show you when we talk a little bit more about speed of some of the interventions we can do at an individual level, which may assist us in some of these spaces.
Thank you. I'll close the poll off now.
Yep.
We'll share that.
Thank you. So, yeah, so most of you are at least, you know, in that frame of mind that we're not aiming for no mistakes on the roads, because we know that is unachievable. We're aiming to minimise the mistakes on the road with what's you know, possible. And gee, we'd all love no mistakes on the road, but when you've got humans in the system, that is not going to happen. And the Usain Bolt one, yeah, I'm sure some of you are trying to calculate that one in your head. 100 meters, 9 point whatever seconds, 10 kilometers per hour. But he did have to accelerate up. So he crossed the finish line at about 44 kilometers per hour. And I'll come back to why I've asked that question in a second. So thank you though for that, and thank you for the interaction. This is good. We'll keep moving on. If we don't get to all the questions today, Kathy, we can come back to them in later sessions, or we can continue to have those discussions offline, and people can email things through if they like. So this is some research that has discovered some of the fatality probabilities for crashes at different speeds. So fatality probability, this is the chance that the member of the community is killed when struck by a car, passenger vehicle, at a certain speed. So what we see here is that when a pedestrian is struck by a car at around 10 or 20, even almost up to 30 kilometers per hour, there's a fairly low chance that they will be killed. Up here around 60 or 70 kilometers per hour, we see that there's a very high chance that they will be killed in that collision. And we see at this 30 kilometer per hour point, it really exponentially kicks up. It becomes extremely severe very, very quickly. And so Usain Bolt comes in a little bit higher up this, doesn't he, in his maximum running speed. So if we parked a Toyota Camry, maybe 2012 Toyota Camry at the end of his lane, and he ran into that at 44 kilometers per hour, will he survive? Well, he's quite high up this curve, but this curve is for our entire population. And we've got very frail people within that curve. And then we've got, you know, people like Usain Bolt, who's like built like the Hulk of a human to withstand lots of force, and he will likely survive that. And in fact, humans evolved to run into solid things off the speed of our own legs. So your maximum running speed correlates quite well with your limitation on force when you run into a tree or a brick wall or something like that. So you can try this little exercise yourself if you want. Run as fast as you can at a tree, and all the science and evidence is saying that you will survive and you will recover to lead a normal, healthy life. Now, there are some abnormalities to that. Occasionally people are killed and the like. So I do suggest you don't actually try that, obviously. But it's a nice analogy to think about. And we have this information for other road users. But let me just show you sort of what we've built to survive. Now, hopefully this streams through for you. Now, these are the things that are recoverable. This guy goes on to recover, breaks a few ribs, recover, and lead a normal, healthy life. Actually went on to win a gold medal a year later or something like Now we have this information for other crash types. So I was just showing you the curve for car hits pedestrian, or car hits cyclist is very much the same as car hits pedestrian. So this red one here is for a right angle crash. A right angle crash, a T-bone crash. And the speed, the collision speed, is the speed of this vehicle, which we call the bullet vehicle. The bullet vehicle is the one that does the damage. This is the target vehicle, and the target vehicle contains the occupant that is damaged, that is subject to the trauma. So the fatality probability in this red curve is actually the driver of this vehicle or the passenger of this vehicle if it's struck from the other side. And we see that around 30, 40, around 50 kilometers per hour is that point where it exponentially kicks up. 50 kilometers per hour speed of the bullet vehicle. And we see this for head-on crashes. This is around the 70 kilometers per hour where it exponentially kicks up. And that's 70 kilometers per hour for each vehicle. Closing speed of 140 kilometers per hour. But the actual forces on the individuals that are involved in those crashes are a 70 kilometer per hour impact, because they go, assuming that we've got two passenger vehicles, same weight, same speed, they go from 70 kilometers per hour to 0. And so it's the equivalent of driving a car into a brick wall at 70 kilometers per hour. Now there's, if some of you are sort of questioning the physics on that, there's a really good Mythbusters episode which explains this in detail, and of course, as they do, crashes cars with accelerometers and into brick walls and into each other. So perhaps, Kathy, we could send around a link to that, because I do encourage the watching of Mythbusters during work time as important research. This line, though, at 10% is so important to our safe system thinking. And the reason for that is it's around that point where things exponentially kick up in terms of the severity of crashes. And what we do in the safe system is start to think about trying to get speeds within these levels where these crash types can happen. So you want to be at or below these speeds where these crash types can happen. And if you can't achieve that, you need to try to alter the system to accommodate that. Now, those that are sort of continuing on to do safe system assessments as part of this, one of the things you do in a safe system assessment, after you've imagined a crash, so you've looked at a bit of road or a design and you've thought, well, this is a crash that could happen. And any of you who are road safety auditors will be very familiar with that, looking to see where a crash could happen. When you get to saying, right, that crash is happening in my mind, what you're asked to do is quantify how bad it will be. And you need to think about the speeds and the vehicle types and the angles and mash all that together. And you would score it between a 4 being absolutely most severe, highly likely to be death and serious injury, down to a 0, which is very unlikely to be death and serious injury in that crash. It's going to be minor injury, bruises, scrapes, bumps, or the like. And you can see that here's a bit of a spectrum which we've sort of mocked up, and there's a lot of bit of work to be done to continue to refine this, but we see different crash types, pedestrian versus heavy vehicles. We know that very low speeds are going to be likely quite severe. Motorcyclist versus car, we know we've got a bit more speed we can get out of that. Then we've got things like head-on crashes, car versus car. We know they're some of the highest speed ones where we're likely to be a bit more survivable. Yep, Kathy?
Thank you, Ken. Just on your previous slide, did the curve, does the data include airbag survival?
Yeah, so the data, this particular one was out of, it's European data from about 10 years ago. The European fleet is significantly more advanced than the Australian fleet, and so there were a lot of airbags in a lot of the crashes they were looking at. But it tried to be a representative sample of what their actual fleet was at the time. So maybe the vehicle technology has gone up a little bit, but I'll show you shortly some of the advantages we can get with airbags and side curtain airbags and the like. And I think some of you will be surprised with how far away from the speeds we travel we are in surviving, even with airbags and the like.
Just another one on speed.
Yep.
Australia can be considered very legislated for all things. How do our statistics compare to the autobahns in Germany?
Yeah, so most of so it's a really good question. I've got a fact sheet directly on this, which I think we should just provide.
Yep.
But the first thing is that the autobahns perform pretty badly in terms of road safety. It's an absolute myth that that they somehow perform really well. The reason Germany performs pretty well in road safety is because their road safety or speed zoning regime and the infrastructure they have is pretty advanced, except for the autobahns. You leave the autobahn in Germany and any residential area is 30 kilometers per hour, enforced by speed cameras. They have something like, I can't remember off the top of my head, it was like 20-1 in terms of speed cameras that we have in Australia. So they blanket their area with speed cameras and they have very low urban speed limits. Their arterial roads operate around 50 kilometers per hour. The autobahns are the exception, and they are likened to the US gun control debate, where it's seen as a cultural right and an iconic part of Germany that this happens, and so it's very hard to change from that particular perspective. But what we've seen in the past 10 years is about a bit over half the autobahns have been speed limited, and they're continually progressing through those because it's, the science and the evidence is unquestionable in terms of the death and serious injury. And then there's a bit of, we'll keep going. We'll send out that fact sheet.
Just a quick one on this one.
Yeah.
Does the head-on account for the speed of both vehicles? I understand, say, a 70-kilometre head-on for both vehicles converts to 100-kilometre or thereabouts. Or will the Mythbusters episode answer this for everyone?
Mythbusters episode will answer this absolutely, and so just watch that when Kathy sends it around, because it'll take me 10 minutes to explain what they explain, and they get to show you cars crashing and stuff.
Excellent, thank you.
So this diagram is the bane of my existence in road safety, and it's not because it's an incorrect diagram, it's because of the way it's used. And I dare say some of you have probably seen this diagram. And what this is it's a crash causation diagram. So somebody has done a crash causation study. They've taken maybe 5,000 crashes and they've drilled down to what they believe the cause of the crash was. It happens every 10 years or so, somebody does the world's biggest crash causation study, and every time they spit out somewhere generally in the same results, which is to say that the road user, here we've got driver written, but it could be, the road user, whoever it is, it's always between 85 and 95% of crash causation. The driver is the one that makes mistakes. The road contributes some of it, and the vehicle malfunction contributes a very small amount. Now, I don't dispute these crash causation studies at all. But what I do dispute is the way that we, as a community, have sort of reacted to this. And the natural reaction is to fix the biggest problem. And we look to think that the answer to our road safety is to fix the driver. Go for the biggest cause. Alter the driver. Give them advanced skills in driving, give them, you know, all of these sorts of things. But we've finally worked out over getting the same data over and over again that we need to fundamentally change the way we look at what we do with that information. And just because the drivers are 90% of the cause, or the road users are 90% of the cause of crashes, does not mean altering them is 90% of the solution. Changing the system around them, acknowledging that failure is part of being a human, and changing the system to cater for some of this is the way we do it. We can still get a bit more out of humans and continue to work to improve things, and we absolutely need to do that. But 90% of the solution is not changing the human. It's changing the system around the human. And I need to remind everybody that human error comes in lots of forms. A lot of the time in road safety, the community, the public, and especially the media get fixated on these deliberate violations. People going at excessive speed or driving, you know, while heavily intoxicated, or you know, on drugs or the like. And they're graphic and they stick in the mind. But there's a whole lot of mistakes that happen out there, which are slips, lapses, mistakes, unintentional violations, which are all pretty much people going about their daily business and having human-like errors, just normal human-like errors. I would argue that these are human-like errors also, but if you put them aside for the moment, what we're actually dealing here with is somewhere between 65 and 70% of our fatal and serious injuries are actually in these categories. We have 30 to 35% down here with these extreme behaviour crashes. So there's a huge amount for us to address just in the everyday people making common mistakes. We may need to treat these slightly differently in the way we try to go about addressing them, because maybe the infrastructure or the vehicles have limitations in what we currently know we can do. Yeah, but it is a lesser percentage. It's still a significant part of our road trauma problem, don't get me wrong, but just thought I'd share that. Let's do a little exercise. And I'm going to have to hurry up a little bit. The good conversation has left me a little bit behind. This is a fairly easy one, just going from traditional approach to road safety to what we're aspiring to move to into the safe system. And you just match. So you might match victim blaming to maximising safe mobility. So if it's coming up on your screen, you've got the ability to do that using the poll. If it's not, you can just look at this slide and you can just type into the Q&A or the chat 1A, 2C, 3B, whatever you want to do to match them up. A few of them could go to any different, could go to a number, but I've got a sort of representation of it at the end. So we'll give you a couple of minutes on that. Just don't spend too long on it. And remember, you're not being marked on this.
And good opportunity for a little stretch break as well, Ken.
Yeah, so pop your answers and have a stretch, get a water, and I'm going to move through the next little bit fairly rapidly.
What do you think, Ken? 30 more seconds?
Yeah, we'll just give it a little bit of time. I see a few people wanting to do that, and yeah, loving the sort of philosophical discussion we're getting happening here, and it's good to get people thinking about these things, and it's certainly a massive health challenge that we face as a society that we need more people thinking deeply about.
All right, well, we might close that off. So we'll just give you 10 more seconds if you're just deciding on that last question in there. If it hasn't popped up on your screen, just pop it into the Q&A. Nearly got everyone there, and I'll just share those results. Thank you, everyone.
Thanks, Kathy. So just have a quick look at these, and then I might talk to them on the screen. But I think most people are generally in the right ballpark there, and I think it's a great way for you to have a think about it. So you can stop sharing those, Kathy, and I'll just show it on my screen. So victim blaming, I suppose we really starting to recognise that human error, minimising its consequence, and that shared responsibility is where we're trying to move to. Emphasis on road user education and compliance. Effort to create a forgiving system is the one that was picked to go to on that one. It could have gone to a couple of others, but it's not to say that we're going to ignore road user education and compliance, very important parts of the system, but one of the areas we've lacked a lot of in the past is that effort to create that forgiving system. Focus on crash reduction, enhanced focus on consequence, especially severe injury minimisation. So the slight difference there is that overall, all crashes, whereas we're focusing on that severe end with that acknowledgement that minor crashes still are going to happen. 4 pillars, action independently. Well, now we're really looking at that joint interactive optimization of the elements of the safe system. And a mobility safety balance moving to that maximizing safe mobility. So a good quote here from Ian Cameron: we need a paradigm shift in road safety policy to stop the road death epidemic, and we need it now. It is unrealistic to expect that education and enforcement alone will bring the needed step change. Even road users who know and follow the rules make mistakes. A safe system creates an environment in which a simple mistake will no longer kill people or seriously injure people. So it's a nice bit of a quote there to summarize what we've been talking about. I think there's any questions or comments before I introduce another little exercise?
We have got a question I might put to you now, and it's going to test my pronunciation of some words. How does a safe system ameliorate the increased consequence injury to people involved in collisions between light and heavy vehicles?
Well, it is a really good question. There's a lack of data around severity injury levels with heavy vehicle collisions, a lack of research and a lack of that biomechanical tolerance curves that we have for other road users. We've got some guesses on it. I mean, basic physics tells us it's going to be worse. We do struggle with sort of 2 vehicle classes in the road network at the moment. The very large vehicle and motorcycles as are 2 that we really don't have great techniques available to us to fit them within these principles of the safe system. So we're going to need to continue to work on that. There are some things we know that can be done. The energy management side of things is very hard, just from the sheer mass and speed of larger vehicles. But there are some things that can be done, and I'll show you through those as we go. Okay, little exercise. It's going to be quick, and I've got a road here, and as you can see, it's got a central barrier system in a flush median and it's a 100-kilometre speed zone. There's a little bit more of it. You can see it's what I'd call a 2+1 setup. Two lanes in one direction, one lane in the other, and then that'll just swap as they go to give an overtaking opportunity every couple of kilometres to one side of the barrier. Now, this project took a very, very long time from its idea through planning, design, consultation, through to actually being built. And the huge number of hurdles and challenges that the project faced is what I want to just briefly talk about. So what I'm going to ask is for you to just type in ideas of challenges, hurdles, reasons this project got delayed 6 months, got delayed another 6 months, got delayed another year, things that they were having to deal with in the design of it, going from a road that was divided by a single white line or a barrier line or overtaking line, so not divided at all, going to this with the central wire rope safety barrier system with a narrow median there. Now, I'm going to give a prize away, Kathy. If somebody, I'm going to write down 2 of the many, many things that could be written down here. And the first 2 people that match those, not that they were necessarily the biggest issues, but they are just 2 that I want to pop in there.
Okay, great. Lots of comments coming through. This is terrific. So yeah, either in the Q&A or in the chat.
Let's have a look what was coming through here. All right. I think, is it? So I had one of them being a motorcyclist, and I think Farouk was the first in there, Kathy. So jot that down as a prize for the first in on that one. And we're seeing there the amount of cut needed, so the widening, the funding implications, property acquisition, vegetation issues, access in and out, heritage issues. We've got weather. I'm not sure, it might be to do with drainage and the like. So loss of dual lanes and the loss of overtaking opportunities at different points. Also another one with motorcycles, noise issues with the audio tactile edge line or vibra line and its proximity to houses. Different aspects of the system itself. I'm just reading through all these fantastic answers. Sight lines around curves and over crests, political issues. So lots of amazing things came in there. It sounds like this group may have been through some of these challenges themselves, because those are all very much things that popped up. The one, I suppose, interesting one, this is a little bit of an aside, the concern about the audio tactile edge line, Victoria took a little bit of a different approach to that to New South Wales. This is in Victoria. And we just roll out audio tactile edge line and then scrub it out if a resident complains, whereas New South Wales obviously has your clearance of 200 metres or 400, I can't remember, from any residents, which makes it very hard to put much of this incredibly valuable, wonderful, low-cost road safety device in. So maybe just something to think about. Oh, and I should mention that hardly anybody ever complains about the noise, and if they do, you just go out and scrub it off. But all of those things absolutely came up, and they held this project back. And there were many, many more that we haven't. We didn't cover emergency access to, the roadside or other vehicles, or the ability to enforce, or the, the over-dimensional vehicles, and all sorts of issues. But the thing that we all know is that this barrier system is going to save a huge number of lives and prevent a huge number of serious injuries. And so what we need to do is be continuing to push and realize that we've got to work through these challenges, and we've got to adapt things, and we've got to make it still happen. We can't lose sight of the overarching objectives. And this is going to come up in all sorts of ways when we're trying to implement the safe system. Continual pushback, because it's not what people are used to. It's different. It's changing the road environment. It's changing the way we use the network. Of course, this one was hit, and it was hit many times, as you'd expect. It's going to get hit. And interestingly, this one, the person involved in this strike actually called the regional office and said, want to talk to the people who put that barrier in. And of course, many of you are on the other end of similar phone calls, and you're always expecting to get shouted at. Well, luckily, or in a very nice way, the person just wanted to thank the engineer in this case and say that I think you saved my life, because somebody came directly at me, and the barrier just pushed them along, and there was no crash. And that was all. Actually, then the engineer was smart enough to get the comms team involved, and they filmed it all, and they made a little 3-minute video, and that's on your memory stick, and I really do encourage you to watch it. It's this road, it's this strike, and it'll give you a good feel for what I say is just a wonderful example of safe system infrastructure. One of the people fell asleep. They should not have fallen asleep on the road. They should have stayed in control of their vehicle. But that happened, all right? And then what happened is that the system stepped in and said, we're going to make this a minor property damage crash. We're going to need to, do some maintenance dollars, need to go to the panel beater, but everybody's going to get home safely to their families. And so that's, what we need to always be focused on, that end objective of what we're trying to achieve. You will come up against so many challenges, but we need to continue to push. And we can, have the same idea as that barrier stepping in through many elements of the system. The Swiss cheese model is sort of the one. In that example, the road user had a big hole, and in order for a crash to happen, it has to find a hole in all these systems. But the infrastructure was the bit of the Swiss cheese model that it did not get through. And it could have been other elements of the system. So I'm just going to briefly touch on a few of these other elements of the system and what can be done. And this is for a few reasons, just so we're all armed on or dispel some of the myths in road safety, and also armed with a few things when we come to doing a safe system assessment that we can inject in that aren't directly infrastructure related, but are part of the system, and also maybe interact with the infrastructure. In terms of road user and safer road users, there is still, we can get a lot out of road users still, and we need to continually invest in this. Education, encouragement, enforcement, and then entry into the system through licensing or the like. Education, we know it works best on the young. That's not a road safety revelation. It's a well-known fact. But certainly if we can integrate great road safety practices into young people, it stays with them for life. But it also can filter up to their parents. You convince these little humans that wearing your seatbelt is a must in the car, and they'll tell their parents to wear their seatbelt or ask them why they're not wearing their seatbelt in the car. So you get, wins like that. Young people are particularly at risk, as we know. A couple of things really. Sending a young driver on an advanced driver training course will increase the likelihood of death or serious injury. Anything that involves high speeds or skids or vehicle control at any speeds, high speeds, is so well proven to increase death and serious injury risk It's one of the best studied things across road safety around the world. The reason for that is that they get these tiny reductions in risk by their increased skills in any circumstances they may need it. And it is massively swamped by the increased confidence, increased risk-taking behaviour, and the belief that they will be able to get out of any scenario. And so are putting themselves in more scenarios. Any driver training that it actually is shown to work is pretty much done at on the public road network or at low speeds in just gaining basic vehicle control. The hours in the car are what actually improves safety in terms of gaining basic understanding on the public road network, how to use it. And some investments in vehicle safety features would be a far greater investment for young drivers. That one is often very hard for people to agree with, especially if they've undertaken an advanced driver training course, because they get the perception that that has somehow influenced them not being involved in a fatal or serious injury crash. The reality is that that is not a statistically significant sample in any form. And as an individual, you can't make calls based on your individual experiences like that in the road safety game. And the odds are just ridiculous in terms of you thinking that that was the influence in you not being involved in a fatal or serious injury crash. So just always in road safety, go to the evidence, the data, and the research to make our decisions, not on personal opinion and personal experience. And it's very hard to do because we all, we're all road users and we all out there and we, experience things. It's a very big challenge when the interface with the public is what we do, and they are, a lot of the public believe they are the experts in road safety because they've been driving for 40 years or whatever it is. They've been riding a motorbike for 10 years and they think they're a motorcycle safety expert. So it's a challenge. Evidence, data, research, that's what we need to go to. A little bit of human behaviour interest is that telling people to not use their mobile phone when they drive because it increases their risk of being involved in a crash doesn't work. It basically, they are conditioned to believe that that is not really the case for them because they only do it when it is safe, or they've been doing it for the last 10 years and they've not been involved in a crash. So this is just a bit ridiculous. It's really targeted at other people who are, watching movies on their phone or something, who knows yet. So we don't get much success. And this is actually the same in speed limits and the like, or speeding as well. Trying to target that individual on their own risk is not a great way to do things. The other reason for this is the increased risk by an individual using their mobile phone is minuscule. It really is absolutely minuscule increased risk, people using their mobile phone or not in the car. But at a collective level, in the whole community, if everybody does it, we have to add up those minuscule risks, and it becomes a very significant risk to our community. So when we talk about this increase in risk from mobile phone use, we're talking at a community collective level, but we're trying to target it at an individual's ears, and they just call us out on it. Like, they just don't believe it. So what you need to do is start targeting other mechanisms to get that behavioural change or that resonation of behaviour change. And this, to me, is a lovely little way of doing that by the TAC, to say, you use your phone while you're driving, and your kids are going to use their phone when they're driving. And all of a sudden, we've got a motivator and a lever and something that is not targeted at that person as such, in terms of thinking that they will be involved in a crash, but gee, they don't want their kid using their mobile phone. So that's just one example of that alteration in messaging that we need to start to craft. And I think we've let ourselves down in terms of communicating speed limits, speed management, some of this mobile phone stuff, and a few others, because the community is just they just don't believe it. A lot of community just go, it's ridiculous. It's revenue raising, and so we need to alter that perception. Whole school approach is the effective way to do things through education, throughout their education career, and continuing that. Combining with other partner activities is great, be that police, be that infrastructure, be that vehicle stuff, and trying to coordinate those messages and that education. A lot of support in the community for improving road safety, and what we need to do is assist them to do it in an evidence-based way, and to be targeting their efforts and their resources and their money at things that we know actually work. And there are lots of things out there that people are investing in and pushing with absolutely the best intentions that we know don't work. Taking kids through the trauma wards to say this is what will happen if you don't, act appropriately on the road network. Proven that it doesn't do anything. In fact, actually has some negative impacts on the kids in other ways rather than road safety. So a bit of assistance in terms of evidence-based. And what we've done is provided these fact sheets for you on your memory stick and in Schoology that has the research and evidence behind these, and these sort of presented as different facts to assist you in this sort of stuff. Graduated licensing works beautifully. Education targeting the parents basically to alter things for their kids, and calls to action are really the go. So I've got those there again, this time with a Wally. So add another Wally to your account. Okay, this is just a bit of a diagram, and I don't need to spend long on this, but it's basically number of crashes based on driver licensing. And you see down here, learners, very low crash numbers, and B-platers straight up there. That's a very good indication that the actual skill is not the issue. It's a lot of other factors in the system causing a lot of the crash, and you see it goes down over time. And even, your most competent drivers aren't operating in anywhere near as much as a learner with a supervising driver. Maybe we're not getting as many vehicle kilometres travelled down here, so maybe it's slightly skewed, but interesting nonetheless. Incentivizing campaigns are an option I think we need to do more of in road safety. We need to consider essentially, trying to incentivize people through insurances or through basically paying them to drive safely through one mechanism or another. It seems to have more impact and more effect. Advertising that specific behaviour, don't drive fatigued is a bit general as a message. Power nap, rest for 15 minutes every 2 hours, or something direct, specific like that is far better. And the way for people to resonate and recall messages is sort of what we use as a proxy for whether it's going to be effective or not. And we know comedy can be an effective mechanism if used correctly in terms of recall. And we want to ultimately change the culture and the way people are thinking about it. And so there are lots of different ads out there. I've popped a handful onto your memory sticks in this folder or in Schoology. Some of them are ads that you see in New South Wales, some are from other jurisdictions. And certainly things like talking to the community about human tolerance to physical force and the, massive difference between the forces we can handle and the forces that are present on the road network. The Victorians use Graham, and Graham is a life-size sculpture that looks scarily human, but is designed to withstand the forces on the road network. So you can see different neck and things. And it's a sculpture that the kids look at and starts the conversation. And there's lots of other stuff around. Why would you need to look like that to survive on the road network? What could be altered? And then you actually run an exercise with the kids in terms of altering the road environment to get Graham back. Like this is a TV screen, Graham, back closer to a normal human by altering the travel speeds, the speed limit, putting barrier systems in place, raising pedestrian crossings, and doing these sorts of things. So the forces come down. So it's a really innovative way, and it's a long-term game to try to sort of shift a culture. Enforcement, strategic enforcement efforts. We don't have enough resources, so it's got to be done strategically, and we need to pull the levers of specific and general deterrence. Specific deterrence being you've been fined for it before, and so you don't do it again, hopefully. General deterrence is the knowledge that you could be fined for anything, and visual presence aids with that general deterrence. Point-to-point speed cameras, and I'm going to have to call out New South Wales on this. You're the only jurisdiction in Australia that only runs their point-to-point speed cameras for heavy vehicles, and that's unacceptable. It's a fantastic initiative that works very well and is generally quite well accepted by the community. So they take a photograph of your number plate at one point, and then maybe 20 kilometres down the road, another photograph, and they average the speed out. And so, if you had to speed a little bit to overtake or some bizarre scenario, you can slow down a little bit and you get that nice general lowering of speed. So I won't harp on about that. I think, so things like alcohol interlocks are a wonderful device in terms of addressing that specific risk of drink driving. So you obviously blow into it, you've got to be 0-0, and then you can drive. We have the technology and ability to do that for speed, the whole network is mapped GIS with speed zones, and the car can not let you speed. We can easily do that, I think the fact is that drink driving has become socially unacceptable. Speeding still holds some sort of social acceptance, which we need to try to work against. And this sort of may be the entry into what was presented as a question before, in terms of like, why do we let these vehicles onto the road network that can go these obscene speeds when there's nowhere they can do that? And maybe because of the challenges in implementing that, we can start by sort of restricting the recidivist speeders, those people who just can't control themselves in terms of speeding, and implement speed interlocks or speed monitoring. We can absolutely centrally monitor speeds of a vehicle at any point at any time, and what the speed zone was. So maybe we can sort of step in that way, which would be, I think, more acceptable to the community, because the majority of the community doesn't like that high speeder, and we can sort of target them. And just proof of the technology. I think this was 2004 in my old Vic Roads car, where that thing told me what speed zone I was in, beeped at me if I was going over the speed limit, and when I got back to the office, we had a central monitoring report of where I may have sped. I didn't speed. I speed on the approaches on the on-ramps to freeways, because the speed zone appears to start on the freeway, not on the part you accelerate. But that was, really about it. In your notes, I've just summarised some of the key points in there. Kathy, I'll pause and see if there's any questions at this stage, and then make a run for the finish.
Run for the finish. Sounds good, Ken. No, we're okay. Yep, all good at the moment.
Okay. So we talked a little bit about airbags and the safety features of vehicles, and there are good safety features in vehicles, and it's getting better and better as we move on. This is the frontal offset test for ANCAP, which is the Australian New Car Assessment Program, and this is to get a 5-star ANCAP safety rating for the frontal offset crash test. The dummy in there needs to not have a forces that would give it a MAIDS level 3 serious injury or higher, which would be fatality, or basically sort of acquired brain injury, major lifelong sort of issues. That crash test happens at 64 kilometers per hour. So we're getting cars off the production line that have 5 stars for frontal offset, and we can only be sure that we're not going to have acquired brain injuries if they crash at 64 kilometers or below. Some of them will be able to withstand higher speeds, but that's that mark. This is the side impact pole test. Still the ANCAP test and the 5-star rating, same thing. Level 3 serious injury for the dummy. And I'll give a prize to the person who can tell me the speed that happens. And a little clue, it's recently gone up. It's very recently gone up, which I thought was quite exciting, but when I actually found the figures out, I wasn't as excited. So the person who guesses that or gets closest will win a prize. You can have a few guesses if you want. Yeah, so keep having your guesses come in. And I'm seeing a couple of notes in there. Yeah, it is a great, so a lot of cars these days have the ability for parents to set maximum speeds, set traction control permanently on, set even the volume of the radio to certain maximum levels. So you can start to, control some of those things. So they're good. And, a couple of the vehicles have that with a specific key. The red key is for the kids and the black key is for the parents. Good little initiatives. All right, anybody getting even close there, Kathy? There we go.
I think we got bang on, Ken.
Yeah, we did. It must be what, Graham?
Graham, yes, Graham with 32 kilometres.
32 kilometres per hour, side impact pole test, 5 stars. That's pretty slow, isn't it? I mean, we're popping side curtain airbags in there and thinking that we've done our job in managing the energy. 32 kilometers per hour is all this test happens at. And that, as I say, earlier this year, was raised from 29 kilometers per hour to 32 kilometers per hour. So we are so far from being able to withstand the forces of sliding vehicles into trees, into power poles, in terms of what the vehicle can do in terms of managing that sort of energy, which is where we need to start to look at other elements of the system. And really the infrastructure in those sorts of scenarios is the answer in the interim. Lots of good stuff coming out around pedestrian protection now. Now the ANCAP has to pass the pedestrian test as well. So most vehicles have their bonnet pops up to a bit of cushioning, or an airbag pops out over the bonnet, or the like, and also cyclist testing and a few other things. I suppose there's a temptation in the road safety game to say, well, the vehicles will just solve all this. Just don't worry about it. Just ignore it until the Google car or whatever takes over. And we see the car with no steering wheels and it does everything. And the time it's going to take for this to happen is immense. And nobody can accurately say when the whole fleet gets transitioned over to this. But, the best minds of this are still talking 30 years, 40 years away before you're even seeing a saturation of the fleet in this sort of stuff. And the amount of trauma and death and serious injury, we're talking, 5,000 people killed in New South Wales at least, maybe, in a 10 or 15 year period. So 10,000 and 10 times that in serious injuries. It's astronomical amount of death and serious injury to the community if you're going to wait for that to happen. And we're not even confident that it'll ever get there in terms of social disparity, in terms of the cost of these sorts of things, in terms of the way that it rolls out, in terms of what do you have, part the fleet that's fully autonomous and part that's not, and how does that interaction happen? And then vulnerable road users and how motorcyclists and cyclists interact. It's not something that we can hang our hat on basically within our careers. Maybe some of the very, people just starting out their career are going to be seeing a hell of a lot more of it. But what we should be concentrating is injecting the best safety features we can along the way. And there is a little bit of thinking in a safe system assessment is the infrastructure making the best use of the technology? Be that lane keeping technology. So are the other line markings clear? Are we blacking out line markings and it's going to confuse the vehicles? Other signs, standard signs, or is something new and weird out there that the car won't be able to understand because cars are reading signs these days? And that sort of questioning. But we don't have a lot of information at this stage, but that's an emerging industry, the roads that cars can read industry, we call that. And we know that, these vehicles, have auto emergency braking coming out, which is wonderful in terms of stopping crashes happening, but also minimizing severity of crashes. So if that stream worked, you would have seen the Mercedes there hit the pedestrian. But what you probably, and so some people would say, well, it's failed. Well, it's actually quite successful because the Merc hit the brakes, slowed down, and just touched the dummy rather than hitting it at the speed it was going when it popped out. So again, I've just summarized the key points in there. Speed is such a critical element of the safe system. We're going to spend our last 7-8 minutes talking about speed. I could talk to you for 7 or 8 days about speed and speed management and speed limits because it's just a fascinating topic. But let's have a quick look at the basic physics and we'll come back to some of this stuff later. Here we've got travel speed. Here we've got distance in meters, and let's plonk a hazard at 45 meters. At 60 kilometers per hour travel speed, there's time for reaction, and then there's braking time. And the vehicle just touches it at 45 meters. Add 10 kilometers per hour. So we go along and we hit it at 46 kilometers per hour. What that says is that speed is not linear in terms of speed of the crash. And so the reaction time is a big factor in that. And so we actually see an exponential increase in some of this, and a power relationship between speed and injury severity of crashes. So the red line here is fatal, and the yellow line is serious injury crashes. And we see here the percentage change in speed versus the percentage change in that crash type. And we see a power relationship for fatal. And it's a fourth power relationship for fatal and a third power relationship for serious injury. And it's actually a second power relationship for all other crashes. So what this says, you don't need to understand power relationships to really understand the theme of this, is that the small changes in speed have their most significant impact on the highest severity crashes, the fatal and the serious injuries. And you can actually get quite good reductions in trauma by small reductions in speed. So, that if you're only getting 3 or 4 kilometer per hour alteration in your 85th percentile or your other speeds, it can be a significant outcome. When we get to speed limits, the community needs, we need to work on the community and alter the messaging in a major way, because we've got at least half the community in this study, at least, that said that they did not believe that lowering speed limits would reduce crashes on the roads. Now, the worldwide evidence says very, very different things. In fact, it says it's highly significant, but we're just not getting that. The females are a bit more clued in this space, understanding that, and there's some interesting stuff on ages and the like in there. But we've got a lot of work to do in this space. We know it works, but the community resists this one. One of the things that they do seem to be quite accepting of is the idea that speed limits would reduce the severity of a crash if it occurs. So that's an interesting little tweak on it. We're still talking speed limits in here. We're not talking impact speed. So that interesting way that the public is just perceiving things. This has all come out of a big report you could download. I've been rewriting the Austrade's Guide to Road Safety part, well, a number of different parts, but part 3, speed management, speed limits. And one of the things I chucked in there was this diagram, which the Swedes like to use. And it talks about, your biomechanical tolerances, basically the amount humans can handle in terms of force. When you can, for any system, understand what their vehicles are, what their roads are like, and what their road users are like. And you can create a safe transport system with whatever has been put in front of you, as long as you filter it through a speed. Now, I think that's pretty obvious to all of us, but it does mean that we need to be a bit more accepting of some alterations to speed. And I'm not at all saying that we need to reduce all roads to, 40 kilometers per hour and, driving down the Newell Highway at 40 or something like that. Well, no, that's not what I'm saying. What I'm saying is that you need to invest the infrastructure to ensure that you can filter through that speed at a high speed, because we need that as a mobility corridor. But areas that don't have that infrastructure, we need to filter through that speed and reduce them to a more appropriate level. But the big challenge is the community and the acceptance of this, and we need to think about that in a very different way, in my opinion. The infrastructure can be altered, so we can achieve safer speeds through infrastructure and/or speed limits. So we can physically put in place things to slow people down, or we can do it with speed limits. The infrastructure tends to be far better if you can afford it. We need to explain why speed limits are in place, because that adds more acceptance to it. And I'm currently just finalising the New South Wales speed zoning guidelines update, and there's much more ability for you to explain why you've put a number in a red circle at a specific location. And protection of vulnerable road users is very well accepted in general. And I think the ability to vary your speeds by time is underutilised in New South Wales, and again, something that we have injected into the update of the speed zoning guidelines. So the ability to use varied speed zones in strip shopping centres, in I don't know, areas where there are nightclubs or pubs and the like, to be able to alter that speed by time of day, kind of the way you do it for schools, but making that far bigger and wider as an option. So some key points on speed. Just a little intro into next week. The international definition of risk is likelihood times consequence. The chance of something happening times how bad it is going to be. For risk across the board, financial risk, health risk, road safety risk. It's all that. In a safe system assessment, we like to extract exposure out of that. So how many vehicles, how many pedestrians, how many cyclists are exposed to this risk? Then what's the chance of a crash? And then how bad will it be? And this is what we're going to focus on for next module and the one after, is categorizing things into these 3 categories. Exposure. So you can alter the exposure by closing roads. Here's blocking off a level crossing, by separating vulnerable road users from higher speed traffic, so they're physically not exposed to the high speed traffic, they're on their own entity. The likelihood is a lot of the stuff that we've done for many, many years, like the signs, the lines, the sealed shoulders, we're doing some wide center lines, audio tactile, even things like traffic signals. These are all changing the chance that crash happens in the first place. They're doing nothing for the severity of the crash, though, when it does still happen. The severity is altered by changing the speed, so maybe slowing vehicles on the approach to conflict points like this one, which is raised platforms on the approach to this intersection, altering the angles of the crashes that happen, or potentially redirecting and deflecting energy. So a safety barrier. So when you hit that barrier, you dissipate your energy over time, which is a way to reduce the severity of the crash. Now, implementing a safety barrier actually increases the likelihood of crash, because you've got far more chance that if you drifted out of your lane here, you would hit that barrier. Because if the barrier wasn't there, there'd be some times you'd drift out and you'd come back and you go, oh my God, it was on the wrong side of the road, but at least I didn't hit anything. And you'd carry on. So we get more crashes when we put in these barrier systems. But the severity of crashes goes way, way, way down. And so we get a net massive increase in safety, but we get more crashes. And so that's a severity outcome. I don't think we'll do the quiz, Kathy, because I'll give time for any final questions or comments, and we just need to alert you to the fact you've got a quiz in Schoology that you're going to need to do ideally before next module. Any final questions or comments come in there, Kathy?
Thanks, Ken. We had some comments around the automated vehicles. And clearly we've got a regional group here. So how do these cars manage to drive on dirt roads? Good question.
Yeah, so a lot of the mapping, so the cars are using a combination of inbuilt mapping with sort of radars and vision, different vision technology. I don't have huge expertise. I've done a couple of projects in trying to understand how we think about these within safe system assessments and road safety audits in terms of how we sort of are catering and thinking about that. We haven't thought too much about unsealed roads and how that would work, but I would imagine that essentially the vehicle fleets would be using things like Mobileye technology. So Mobileye are sort of pre-fit in existing cars. But what they're out there doing these days is mapping the network. So if you've got a Mobileye device in your car, you're mapping the road network for Mobileye, who then sells it onto the Google cars or Volvo's autonomous cars. So it's pre-read the road and got an understanding of it using sort of AI technology. So the physical infrastructure may not be specifically like the line marking things may not be a primary requirement. It's often used as a secondary backup mechanism for the vehicle as well. So it's a bit of a funny space at the moment. You can't get much out of any of the manufacturers or the Mobileyes of the world, the tech, because it's all their intellectual property and they don't like sharing it and telling too much. But it's the sort of stuff we're getting to know these days.
Just a comment on earlier when you talked about the ANCAP tests and the pedestrian protections. The reason we can't have bull bars for work vehicles, even though we run the gauntlet when we're at work late, especially in winter, experience of cars written off due to kangaroos. And something probably quite topical for New South Wales. Have you considered food delivery drivers as a threat or riskier than normal drivers?
Yeah, so the food delivery drivers and riders of all their descriptions are certainly an emerging challenge. And I think this is an interesting one where workplace health and safety really needs to start kicking in, because there is behavioural challenges, but there's also other system challenges in terms of the vehicles, the lack of safety gear, the accountability in terms of sort of ways that the road network is being used. So it really is, in my mind, if we could genuinely get those people to be, or those organisations to take a occupational health and safety responsibility, we would see a very altered system in that space, and that's the way I think we need to be attacking that one. It's just gone over 12 o'clock, Kathy, so I think we better hold it up. But what a wonderful group in terms of conversation, great questions, great thinking, and I'm really excited for the next modules as we continue this conversation. So get into Schoology, answer your quiz. If you have any challenges, contact Kathy. Otherwise, we'll see you at the next module. Come in 3 minutes early for a chance to win a prize.
Terrific. Thank you, Ken, and thanks everyone for your participation. See you Thursday.
Bye.